Hello everybody! Today I'm going to talk about binary trees. Binary tree is an amazing data structure. So let's see what it is. Binary tree consists of nodes. On the top there is a root node and all others below are children's. Up to the leaf. Leaf is a node which doesn't have any children. So let's see what is a binary tree itself. There are a few different types of tree structures that are used in programming, but the most common and most powerful one is a binary search tree. So, let's see what it is. A binary search tree must be sorted in a specific way, which makes it searchable. And that means that all nodes on the left from the root should have smaller values than the root value. And all nodes on the right should have bigger value than the root. Well, what it gives to us? Well, first of all, if you want to insert a new value, it will be placed in a right sorted order, and it takes only log n time to do that. Same for delete and get for a balanced tree. For example, if I want to insert 33 over here, I compare it with 41. Is it bigger or smaller? If it's smaller, we're going to the left over here. And now we compare that with 21. 33. Is it bigger or smaller? It's bigger. Then we're going to the right and insert it to the right if there is no more trees, no more leaves. Okay, so let's see how can we implement the binary tree. I'm going to implement a tree node itself and say two methods, one for insert and one to print out. Okay, let's implement our tree node class. I'm gonna have two methods, insert and inorder print. I'm gonna implement a tree node because there is no need to implement separately node and binary tree. It actually makes the implementation even more complicated. Why? Because even if there is one node only, it already can be called a binary tree, just that left and right children are nulls. Okay, so let's see how it looks. I'm gonna have two pointers here, left and right. Okay, with the same type. And I'm gonna have one integer value for my data, which that node will hold. That's it. And let's create a small constructor. Public 3 node. Okay. Okay, so let's implement insert. First of all, let's think how it works. We need to compare our value with the current node, with the root node. If it's smaller, it goes to the left, right? So first of all, I want to check if my value is less than myself data. If it is, I want to insert it to the left. Of course, if the left is available, if there is no children left node. So if left is now, if there is a space, I'm gonna insert it. So left equals new tree node with value. Otherwise, I need to go down to find a space where left is available, right? Else, I'm gonna call it recursively on the left part, the insert method value. Got it? And same we have to do on our right part. Otherwise, when my value is bigger than the current data, else I'm gonna check if there is a space on the right. So if right equals null and it's bigger, I wanna insert it in the right. Okay. Otherwise, I'm gonna recursively go down and check for the space. So I'm gonna call insert method on the right part. Okay, the trees is what's amazing about trees. It's a recursive data structure, so we call recursively down and down on the right and left part till we find a space. Let's print our tree. Again, first of all, I'm gonna check if my current node, how we're gonna, no, blah blah blah. Let's check it out. First of all, let's think how we're gonna print it. In order means that we're gonna print left part first, the smallest value, then we're gonna print root, and then the right part, the biggest value. So if we have a values on the left, if left are not null, if it's not nulls, we're gonna go below, right? We're gonna go below to the very beginning when the left become null. So we're gonna go all the way down. That means we're gonna call our printing order always there till the left is null. I'm gonna put it in a stack, and then if it does, I'm gonna print the current node, print myself. Then we go up, down till the root and check the right part. If right is not null, we're gonna put it all the way down with recursive call. And that's it. Thank you.